Hello there, and welcome to lecture 2 of this module. I'm sure you remember we discussed about Scala and richness of the language it provides. We talked about its conciseness, compatibility, and interoperability with Java. Scala is a powerful language because of supporting multiple programming paradigms such as functional as well as object-oriented. Remember, we had a look on object-oriented design's principles such as encapsulation, abstraction, inheritance, and functional programming domains, important concepts like immutability and referential transparency. We also gave reasons that Scala provides mechanisms to take advantage of parallel architectures into our program. To become a good productive developer, one needs to know the motive and base on which a language is constructed upon. You have got to know all the toggles and the gizmos that make up a language's infrastructure. In today's lecture, we will talk a bit more about Scala language features to get more insights. Where it all started. Martin Odersky and his team started development of Scala in 2001 in the Programming Methods Laboratory at EPFL. Scala made its public debut in January 2004 on the JVM platform and a few months later on the .NET platform. The root reason to create Scala was to unify two paradigms into one. Martin says that two paradigms are two sides of the same coin and to be unified as much as possible, and does the same with Scala without compromising with interoperability between the two. In Scala, everything is an object. Believe even operators like these. Say 2 plus 3. It looks simple, and indeed it is. But Scala interprets this as 2 and then a method call to plus and passing parameter 3. If you see, this means that you are invoking a plus operator on an integer object, that is 2 in our case, by passing as a parameter 3. Along with the pure object-oriented features, Scala has made some innovations in object-oriented space, and that is beautiful. One of them is modular mixin composition. A mixin is a class that provides certain functionality to be inherited by a subclass and is not meant for instantiation by itself. A mixin could also be viewed as an interface with implemented methods. A mixin does not depend on any methods or fields of the class that it's mixed into, but sometimes it's useful to use fields or methods of the class it's mixed into. This feature is called self-typing. These are some of the concepts we take from object-oriented space and are either simply a part of Scala or refine the way we can use to make more efficient. On functional ground, Scala has much more to offer, and of course, just because Scala is a functional programming language, or I would say basis for Scala is functional programming. Functional programming takes more of a mathematical view of the world, where programs are composed of functions that take certain input and produce values and possibly other functions. If you ask yourself this question, that how do mathematical functions relate to functions in programming? I would say in mathematics, a function is a relation between a given set of elements called the domain. In programming, we call this input, and a set of elements called the codomain. In programming, we call this output. The function associates each element in the domain with exactly one element in the codomain. For example, let's take a look at this function. F is taking an x and it's resulting in y. It could be interpreted as x has a relationship f with y, or you can say x maps to y via f. If you write your functions keeping in mind the definition of mathematical functions, then for a given input, your function should always return the same output. Let's take this example. We have a method fx is equal to y is equal to 2 cross x. That is, we are multiplying every input 2 times and returning back the response. And above function will always return the same result for the same input. If you think of a functional language, consider that language provide you at least some of the following features. And features are higher order functions, lexical closures, pattern matching, single assignment, lazy evaluation, type inference, tail call optimization, list comprehensions, monadic effects. And guess what? Scala provides all of them. Regardless to say that Scala is not a pure functional language, right? It is possible that while browsing web or reading a book on functional programming could lead you to this statement: pure functional languages promote functions without side effects. What is a side effect anyway? Let's discuss. What would you call a side effect in normal context? I would say an unintended outcome of a process. Same is in functions context. A function or expression is said to have a side effect if, in addition to producing a value, it modifies some state or has an observable interaction with calling functions or the outside world. A function might modify a global or a static variable, modify one of its arguments, raise an exception, write data to a display or a file, read data, or call other functions having side effects. And in the presence of side effects, a program's behavior depends on its history of executions. Scala supports immutable data structures and constructs. When you define your attributes using where and val, it means two different things. Var means variables that can vary after it's defined. See, we have a var and a val. We have defined a var named Spider-Man, and when we are creating a new object of Avengers with that, as you can see, it's a variable, so we can change that into a new object. So now Spider-Man is referring to a new object. Thus you can see that we have changed the character for that. From Tobey Maguire, it's now a new actor. So I would like to say, if we are using val for the same and we are declaring it as val Spider-Man is equal to new Avengers, and try to change that object with the new one, like Spider-Man is equal to new Avengers, that won't be possible. See, because I told you var and val are two different things. Value point to an immutable data type. Value Spider-Man is going to be an immutable object, so we cannot change that further. So let's have some food for thought. What may happen if we have something like this? Val Avengers is equal to new array of Avengers. And given this example, if we add values like Avengers 0 is equal to new Avengers, yeah, this is a way we give indexes into Scala. We use these small brackets. Don't worry about that. We'll take a look. And don't guess if you are, think of it. I would say think of it. What vals and vars really mean? A value means you cannot change what an attribute is pointing to after it's once defined, means an object. And here we are not changing an object. Val named Avengers is not trying to point to a different object after it's defined, and we are only adding Avengers to that array. And hence it is simple and a doable thing. I suppose you might have some idea about where and val now. And as you gradually go ahead and experiment more and more, you will find many rich features Scala offers. We haven't even touched what implicits, lazy initialization, currying, extractors, abstract types are. And still we can feel the richness of this beautiful language. Now, that gives you a firm reason to learn Scala and to use it. We'll be using it in our next lecture anyway. So, I would ask you to remember this. According to Timothy Budd, research results from the According to Timothy Budd, research results from the psychology of programming indicate that expertise in programming is far more strongly related to the number of different programming styles understood by an individual than it is the number of years of experience in programming. And this is true in Scala's context. The richness of object-oriented design has been welcomed and limitations have been removed. Type inference is a solid example for that. So you have a sense of purpose about Scala now. And that was my objective for this lecture. One of the reasons why Scala is extensively used in other frameworks and toolkits, we will have a look at those in a bit. First, let me tell you, because of open Scala specification and because of rich documentation, it always has the capabilities of becoming the core of any other framework. Scala's conciseness, actor concepts are used in frameworks such as Lift, Akka, and Play. So we will discuss them one by one. First, let's discuss about Lift. What is that? Lift is an expressive and elegant framework for writing web applications. Lift stresses the importance of security, maintainability, scalability, and performance, while allowing us for high levels of productivity. Lift open source software is licensed under an Apache 2.0 license. The Lift web framework has commit support. That means that state change on the server side is immediately pushed to the browser. Lift's commit support makes chat applications, multi-user games, and other browser-based applications trivial to write. Akka is a toolkit and runtime for building highly concurrent, distributed, and resilient message-driven applications. Using Akka provided actor model, we raise the abstraction level and provide a better platform to build scalable, distributed, concurrent, fault-tolerant, resilient, and responsive applications. For fault tolerance, we adopt the let it crash model, which the telecom industry has used with great success to build applications that self-heal and systems that never stop. Akka is open source and available under Apache 2.0 license. Play. Play 2 provides an asynchronous HTTP API leveraging on the actor model by means of Akka to handle highly concurrent systems. Akka is an implementation of actor model for both Scala and Java. Play 1 used the Java language and provided support for Scala by means of plugins, but Play 2.0 was released in 2012 and was written in Scala in concurrence with TypeSafe 2 stack. Play has extensive set of features for web architectures such as asynchronous I/O, input-output, built-in web server, dependency management, hot reloading, in-memory database, native Scala support, ORM, stateless APIs, templating, its own testing framework, WebSockets, and much more. It comes in a standalone and activator-based distribution. Next is a different one. It is a front-end framework, Scala.js. Developer community was thinking, why not use Scala's great features for front-end development? And this has really made front-end development easier. Static typing capabilities of Scala has let front-end developers define variables in their code and things are easier for them now. There are other libraries such as Breeze, Scala NLP, Algebra, and those are great Scala frameworks for linear algebra, numerical analysis, and machine learning. They provide even the most seasoned Scala programmers with a high quality layer of abstraction. Let me tell you the truth. I am extremely excited to get you guys to smell the real Scala code now after knowing so much about Scala's features and offerings that it is giving to us. So we will go ahead and do that in our very next lecture. For now, let's do what we should do at the end of every lecture. We will summarize what we have learned. We learned Scala's motive of unifying two programming paradigms. We learned that everything is an object in Scala. We learned about object-oriented tools and tricks we used with Scala and how we define them using the newer constructs that Scala provides. Mixins and implicits were one of them. Then we landed on functional ground of Scala. We covered that. We learned how mathematical models support functional programming. We learned about wheres and vals. Then finally, learning all these was fun. Not just because we got to learn something new, but also we are going to use them now. And it will all come to us, believe me. So, thanks for your time, and I expect that it was worth investing. See you guys in the next lecture, and thanks and happy learning.